All right, which element is easiest to find first? Angle A. This is what you need to find first. So let's see if we can find angle A. So we'll take the sine of A over the side opposite it is equal to the sine of the known angle, sine of 47 over the side opposite it, 11. And so this allows us to solve for our angle. Multiply both sides by 12. And so to find what the sine of A is, or to find what angle A is equal to, if we know that the sine of A is equal to this ratio, so if we take the sine of 47 times 12 divided by 11, put it in decimal form. So here's what the sine ratio is for angle A. If we know that that's the case, 0.798 approximately, how can we find what angle A itself is equal to? I'm going to take the inverse sine of this ratio. Now, when you do this, don't ever round your number inside here. And so if you took the inverse sine and you typed in 0.798, you might come up with a slightly wrong number. And you have to use the exact answers all the way until the very final result, and then you can round it at that point. So here your calculator has this. It's the last entry, so if you just take the inverse sine, and you can either scroll up, highlight that, and put it in, or you can just use this answer key, the second function, change the sign. It gives you the answer from the next step up. And then you hit enter. This is your angle measure. So to the nearest whole degree, what can we say angle A is approximately? It is about 53 degrees. And so if we wanted to find then what angle C is going to equal, what could we now do? Do we need to use law of sines to find angle C? No. Now we can use the triangle sum. 53 plus 47 gives you a total of 100. So what does angle C have to be? 80. And so now what can we do to find, once we have that angle, now it fits the pattern of ASA or AAS, so we can use law of sines once again to find C. This time we can set up our ratio C over the sine of 80. And now here's where you want to be careful. When you're calculating, I want you to use the exact answers. Okay, so what you would need to do to find out what C is exactly is you'd need to actually take this number, add it to 47, and then subtract that from 180. And so I'm just going to subtract 180 and change the sign here. So this is actually 80.075. So when I take my sine of this number, I'm going to use that actual value. And that's equal to, and which one is the more accurate side and angle measure? B. So we set it over the ratio of 11 to the sine of 47. So when we take this answer, multiply both sides by the sine of 80, but you're going to use the exact value. So here when we calculate this, we're going to take the sine of this number. Okay, I'm just going to go up and highlight it and then change the sign back to a positive. And so here's our exact angle measure. So it's the sine of 80 times 11, all divided by the sine of 47. Hit enter, and you have your side of 14.8 approximately. Okay, so I will almost always have you round sides to the nearest tenth, angles to the nearest whole measure. Okay, but you still want to use exact answers anytime you're calculating. And now, is this consistent with what you would expect based on angles and opposite sides? Are the longest sides opposite the largest angles? Yeah, the smallest side opposite the smallest angle? Yeah. And what if I told you, though, that there's another triangle that has these same starting pieces of information, side of 11, side of 12, and an angle of 47? Okay. who's to say that this angle C is not necessarily 80 degrees, but you know that side AC is 11? Is there any other place where side AC could possibly be? Oops. What if, again, and this isn't necessarily drawn to scale, but what if here's my length AC? Is there another place where this will pass through the side to create an alternate triangle that still has sides of 12, 11, and an angle B of 47 degrees? Yeah, so this sliver of a triangle right here, this red triangle, also fits this pattern of sides of 11, 12, and an angle of 47. Okay. So how do you think I might be able to solve for the other possibility? So we have one possibility. One possibility is angle 47, 53, 80 with a side C of 14.8. It's another possibility, this red triangle. We still have an angle of 47 here. But how can I tell what this new, I'll call it A2, what's this new angle A going to be? Any way to find it? What type of a triangle did I create when I marked this off here? Distance AC, 11, is still equal to 11. So what kind of a triangle is formed right in here? An isosceles triangle. What would this angle measure be based on our calculations from the first example? About 53, right? So what does that mean the other possible angle A might be? 180 minus that 53. Now, if you take 180 minus, remember our angle wasn't just 53, it was 53 point something. So if you have your calculator, and that's the nice thing about using these, you'll have all your values stored in your display, don't erase them. And just scroll up, here's our actual angle measure. So we can look at this value of 127, add it to the 47 that we already have. Can we find what this other angle C, this new angle C, is going to be? Yeah. Take this value and subtract it from 180. So if we take 180 minus, highlight that, we get an answer of about 6 degrees. Now, again, if you added those together, would you get 180? Yep, so there's our angle measures. And so how could we now solve for C2? This new length here. C2 over the sine of the angle opposite C is now 6 degrees. And that's still going to equal this 11 over the sine of 47. And so you can calculate this, again, kind of going back to what you had. If you take 11 times the sine of this 6 degrees, which is, here's the exact answer, so I'll put that, enter that in my calculator, and then that whole thing is divided by the sine of 47. Hit enter, and my new side here has a length of 1.6. Again, if I'm rounding to the nearest tenth. Is this consistent now with what you would expect? The smallest side 1.6 opposite the smallest angle of 6 degrees, the longest side 12 opposite the largest angle 127. Is that still consistent? Yeah. Does everybody see what I did on that? And now, what if I told you this isn't always going to work? Okay, so let's take a look at another example, and we're going to see if it does or doesn't work, and then see if there's anything that you can compare to show why they do work. All right, so I want you to find side A, angle C, angle A. So which angle do you, or which piece of information can you find first? C. Okay, so we take sine of C over the side opposite at 7 is equal to the known pair of angle and side, sine of 50 over 10. And we can solve for C. Sine of C is equal to, and if we calculate this through, we get the sine of 50 times 7 divided by 10, put a decimal form, or put it in decimal. So we get approximately 5.36. So C is going to be the inverse sine of whatever this ratio is. So we can simply take that inverse sine, highlight the actual ratio, and we get about 32 degrees. And now, because of where it fits here, how close it is to the middle, it doesn't really, I mean, it's right in the middle, rounding up and down. I mean, it would round down. 32 degrees would be to the nearest whole degree. But let's just go ahead and go to the nearest tenth there. So 32.4, what does that mean angle A is going to be? So we can take 180, subtract the 50, subtract the 32.4, and that gives us about 97.6. Now again, if I round it to the nearest tenth, is this consistent? Do I have triangle sum maintained here? Yeah, so we've met that condition, okay, which now allows us to find side A. Side A can be found by taking the law of sines once again. A over the sine of the angle opposite it, 97.6, is equal to the pair that you have to start with, 10 over the sine of 50. Multiply both sides by the sine of 97.6. And you'll get your A value, so 10 times the sine of, and I'm going to access that exact answer, and then divide that by the sine of 50. And that gives me about 12.9. And now, is this consistent with what you would expect? Again, longest sides, opposite, largest angles, smaller side, opposite, smallest angles. Okay, so this is consistent. All right, see if you can figure out what the other measures would be. What would be the other possible angle measure for C? Can it work? Let's talk about whether it can work first. Okay. If we sketch this length of 10, what do you notice about this triangle? It's going to have what kind of angle right here? Obtuse angle. So we know that that would have to be greater than 90 degrees, yes? If this was greater than 90 degrees and the side opposite it was 7, is it possible for the side opposite 50 degrees to be 10? No. Do you see how that's inconsistent? Okay. So what's the only time?
Well, you have to turn it so that the two sides, they're the greatest.
Well, again, that's how you can decide which one actually works. What's the difference between this versus this one that actually did work? Where's the longest side of the two? It's right here. It's the one that's connected to the angle. Whereas in this one, the longest side is opposite the given angle. Okay, so if the longest of the two sides is opposite the given angle in that SSA pattern, okay, and so if you have SSA with the longest side opposite the given angle, there's only one triangle. And whereas if you have SSA where the shorter of the two sides is opposite the given angle, now you're going to have two possibilities.